Today we'll start with sampling. Now, before going into the sampling, I'll just recapitulate a little bit. When we have started doing our discussion on statistics, what I have suggested that initially we have said that statistics is combination of four things. Can somebody tell me what are those four things? Hmm? Data collection, then representation, then
Sampling.
analysis, and lastly interpretation. So previously we have already studied collection, representation, some part of analysis we have studied. But now we are going into the details of analysis and interpretation, and we will define certain things first, then we will go to the details. What do you understand by the term population and sample? Population and sample. So who can tell me what is sample and what is population? Say, suppose we are trying to find out, say our objective is to find out all the uh, residents of India uh, and their average, what is the average earning per month. Whoever is working, working class, working middle class, or whatever, what is the average earning of the people of India. So to do that, it's a very difficult to do, because for that reason every household has to be surveyed, and there the question has to be put through, and we have to ask that what is their income, what is who are the earning members, and so many questions like that. Now, not everybody will give the proper answer, so that's a very big task. Instead, let's take another example. We'll be discussing something about population and sample. Let's try this example. Uh, think about, there are in Swami Vivekananda group of institutes. There are several colleges in under Swami Vivekananda group of institutes. There is Swami Vivekananda group of management and computer science. There is Swami Vivekananda group of college of Institute of Science and Technology. There is Regent. There is Modern Science. Swami Vivekananda Institute of Science, Modern Science. So there are several, and if I want to find the average height of all the students, so that will be a very tedious job. If I want to find the average, my objective is to find out average height of all students of SVGI group. So that's quite a tedious job, because in SVGI group, under SVGI group, about 40,000 students are there. So about 40,000 students are there, and so that means I have to go to each and every student and measure their height and then take the average. So it's a very big job to do, and I cannot do it very easily, because in a day everybody will not be present, or maybe uh, some days some if some students are there, then other students will not be there. So I can face several difficulties. So what are the difficulties that can be faced? Can somebody tell me? So, and what are the advantages and disadvantages? Who can tell me? So this 40,000 people, students under Swami Vivekananda group is called population. Now instead of that, what I can do, I have MBA first year in Swami Vivekananda Management of Computer Science. I have MBA second year in Swami Vivekananda Management of Computer Science. I have I have modern science students, some. So what I can do, instead of going to each and every class of Swami Vivekananda group, I can choose a particular class and measure the height of the students of this class. So this says, suppose these three classes like BBA second year in uh, modern science, uh, MBA first year in Swami Vivekananda Institute of Management and Computer Science, and MBA first year in Swami Vivekananda Institute of Science and Technology. So if I choose these three as sample and measure their heights, and I can find the average height of the students. Say maybe there are 40 students in this class, maybe there are 25 students in this class, and maybe there are 35 students in this class. So 35 plus 25 is 60 plus 40. So I have chosen 100 students, so I can measure their height very easily, and then I can find out the average height of the students. That becomes very easier to do. So this these classes can be taken as sample, and the objective could be fulfilled, and I can find out the average height, maybe it comes as 165 centimeter approximately. So I can say that the average height of all the students of Swami Vivekananda group is near about 165 centimeter. So now this, all the students of Swami Vivekananda group will be termed as a population, and these three classes, these three sections will be termed as a sample. Will be termed as sample. So by doing this sampling means making the process of taking sample. So how to do the sampling? So by taking the samples, we can get the idea of the different characteristics of the population. So population is the whole thing, and the sample is the part of it. And it's very important to note that everything about the population is unknown, and everything about the sample is known. So our objective is to, looking at the sample, we have to try to decide the characteristics of the population, and that is how the interpretation and analysis part will go in statistics. In statistics, the last two things are analysis and interpretation. Now I can give a very simple example. In our house, we how we find whether the rice whether the rice is cooked or not. So for that, what we do, we pick up a spoonful of rice from the whole bowl of rice that has been being cooked, because unless we are happy with the, then what we do, we check that small handful of rice whether that amount whether that particular amount of rice is cooked or not. If we are happy that amount of rice is cooked, then we are happy with the whole bucket or whole the bowl full of rice that is cooked. So what we do, this is the handful of rice, and this is the bowl full of rice. What we do, we take this handful of rice and check it. So this is what is your data collection, and this checking means is your analysis. You check on that handful of rice, and if you are satisfied with that sample, and so this, what we are doing, we are choosing a sample from the population. This bowl full of rice is the population, and the handful of rice is your sample. So we are analyzing the sample and checking whether that rice is cooked or not. If we are satisfied with the sample, then we are satisfied with the with the population. We decide with the help of the sample whether the whole bowl full of rice is cooked or not. If the handful of rice is cooked, then we decide the bowl full of rice is cooked. Or if the handful of rice is not cooked, it will take some more time to cook. We will decide that, so okay, let's wait for some more time so that the bowl full of rice will be cooked. So this is the perfect example of sampling and sample. So that sample is something where everything about the sample is known, and population is something where nothing is known. With the analyzing the sample, we would like to know the different characteristics of the population. Our objective is to know the characteristics of the population, and for that we have samples to analyze. We don't have the whole population to analyze. We have some parts, either single sample or some samples with us to analyze, and analyzing the samples we can uh, decide about the population. Now it is important to know that whether a small sample, one sample is sufficient, or a number of samples are required. So that will be discussed in the future. I'll be saying this time and again that everything about the population is unknown and everything about the sample is known. Now there are certain characteristics of population and sample. So I'm enlisting the characteristics. In general, a population characteristic is termed as a parameter. Population parameter means population characteristics, and a sample characteristic is termed as a statistic. So let's, from now onwards, we will not say mean, median, mode, or standard deviation like that. From now onwards, we will be saying population mean, population standard deviation, population size. Like capital N, from now onwards will be denoted by population size, and it's a population parameter. So, and similarly, sample size will be denoted by small n, so which is a particular kind of statistic. Sample size will be small n. Then we will denote mu as population mean, and we will denote x bar as sample mean. Sample mean. We will denote sigma as population SD, standard deviation, and we will denote S as the sample standard deviation. Mind that I have already said the population characteristics in general are termed as parameters. So N, mu, sigma, all of them are different population parameters, and x bar, small n, x bar, small s are all sample characteristics, are all of them are different sample statistics. Sample statistics. So population characteristics are called parameters, sample characteristics are called statistics. Now our job is, with the help of the statistics, we will be trying to find out what could be the possible values of the parameters. So let's go back to the example that I have found out that the average height of the students of these three classes were, I said, x bar was 165 centimeter. I have said. So x bar, that is x bar, because we have chosen sample, and sample we have taken the average of those sample and I found out 165 centimeter, and from that I can interpret, I can decide, I can, by some way or the other, if I can say that the average height of all the students will be around 165 centimeter. So that is our objective. So looking at the sample, we will use sample characteristics, we will be analyzing the sample to find out some similar characteristics with respect to the population, and by finding out the different characteristics of the population, we can predict, we can try to find out how the population will behave, and accordingly we will act. When I have started statistics, I have told you this example, if I remember correctly. Say, suppose we are we want to find out whether in our locality or in your locality, where say somebody stays at Sonarpur, where our college is. So, my objective is to find out whether there it is feasible, it is possible to make a mall so that people will come over there and buy the things from the mall or not. So, but and in Sonarpur, it's a quite a long area. So in the Sonarpur, from Sonarpur Kamalgaji to Sonarpur station, this is the road going on, and somewhere in between in Karbala, we want to make a mall over there or not. So it is now the company who wants to set the mall wants to check whether it is feasible that there will be whether the mall can be made over there or not. So for that reason, what is needed to be done? Can anybody tell me? So we have discussed that it is to be surveyed whether the people in and around Sonarpur has the buying power or not, whether the purchasing power, whether the capability of buying from the mall or not. So that could be one objective. So for that reason, what we need to do, but in and around Sonarpur, that particular area of say 3 kilometers, 2 kilometer radius, if we take the people over there, there are a number of people situated having staying there. Maybe there are, say, suppose there are say 10,000 families, 10,000 families stay over there. So for that, a survey is to be conducted to these 10,000 families to know what is their, how many members are there, what is their average income, what is their monthly income, what is their average spend, how much they spend in their buying food and buying clothes and all those. So all those information needed to be collected. But it's not a very easy job, because this 10,000 families will constitute the population. So if I choose say 5 students to survey this 10,000 families and tell them, okay, go and survey, that will be a very tedious job to do, because for 10,000 families, if I choose 5 student group, then each student need to survey 2,000 families, and which is not a, and if I give them 2-3 days time to survey, that is not a, they will not be able to do that. So instead of that, what they can do, they can divide the whole area in 4 or maybe 5 parts, maybe some regions like this. So 1, 2, 3, 4, 5, the whole area, and they have everybody from this particular region, everyone chooses say 50 families from each region. So as I said, 5 students. So in this area they choose 50 families, and for them they will survey these 50 families. They have to keep it in mind that all kind of people should be included in that case, in that survey, otherwise proper information could not be gathered. So this is how we can, and with this 50 to 5, that is with this 250 families, we will gather the information about the 250 families, and analyzing this 250 families information, we will try to decide whether the people in and around Sonarpur will be coming to the mall and buying the products from there or not, and that will help us to decide whether the making the mall is feasible in the Sonarpur area or not. So that is how the process goes. So instead of surveying each and every, because that will be a very tedious, time consuming, costly process, enumeration, that process is called enumeration, and that's a costly process, because going to each and every family and collecting the information, collecting the data from there is a, not everybody will be able to give the proper information, they will not give, so there are several difficulties that may be found out. So but if it could have been done that way, better result could have been found. So whenever we try to survey, instead of going to the each and every family, instead of that, if we are going to select a few families in between, then the cost of data collection will be less, it will be done more proper way, but result could be a little bit erroneous, because we are not so, because we are not asking the whole. Instead of the whole, we are dealing with the, instead of the whole we are dealing with the parts. So part is the sample, part is the sample, and whole is the population. So as we are not dealing with the whole population, and we are missing some part of the population, so exact information could not be collected, fully correct information could not be corrected. There will be whatever decision we will be taking, analyzing the sample data, there will be some amount of error associated with it. So but it will become much more easier to do, much more easier to analyze, much more easier to gather the information, and much more less time consuming, less cost will be involved. So these are the advantages of doing the sampling process rather than doing the enumeration. So enumeration is something where you have to go to each and every family and ask these questions, and that's a tedious job, difficult job, time consuming, cost consuming, and but advantage is you will get a whole picture of the whole information will be could be gathered. But instead, if you take the sample, several samples, if you take, the cost will be less, time will be less, it will be easily conducted, and the information gathered will be somewhere more or less good, but not exactly 100% correct. There will be some amount of error within it. Let's give another example. In case of manufacturing industry, what happens? Daily, a lot of the daily production ranges from, say, think about the Coca-Cola plant. Daily, about 10,000 bottles of Coca-Cola, say 300 ml Coca-Cola bottles are being made. But how they could do that quality check? So this 10,000 bottles of Coca-Cola is your population. But instead, it is very difficult to check each and every bottle of Coca-Cola taste, and I am talking about the quality control or quality check of the finished product. I am not talking about the raw materials and all that. So raw materials are processed and the finished goods are being made, and it has been after the it will, so 10,000 bottles will be already produced today, and they will be packed and sent to the market. But how the batch of this 10,000 will be processed? To process this 10,000 bottles, it's very difficult to check each and every bottle. So instead of that, what the quality control inspector does, he randomly picks up say 100 bottles, 100 Coca-Cola bottles, and checks these 100 bottles. If he decides, okay, if there are greater than 3 problems, 3 bottles, more than 3, if out of these 100 bottles, there are more than 3 bottles have some problems, then he will reject this particular batch. So that is how the quality control is done. So what it does, he analyzes this sample of 100 bottles, checks for the taste, the whether it is the bottle contains the mark 300 ml or not, whether the color, whether there is anything in the bottle or not, whether it is washed properly or not. So those things can be done very easily with 100 bottles. Instead of 10,000 bottles, it is possible to check this 100 bottles very easily. So if he is satisfied with this 100 bottles, he is satisfied with this 10,000 bottles. So if there are less than 3 bottles which are incorrect, so this he passes that batch. So that is how in manufacturing industry, I am giving this example in a very crude manner, very simple manner. Something more has also been done, but this is a kind of sampling is always used in manufacturing industry to use it in the quality control process, so that the daily production for the batch that is being produced per day. So for the quality control of those batch, the sampling is used, and the samples are checked thoroughly, so that they can be that batch could be passed to the next set of journey to the market. So sampling is a very important technique in the manufacturing industry for quality control process. Now let's define what is sampling. Sampling is the process of making samples or taking samples from the population. Now there are several types of sampling process involved. Most commonly used sampling is simple random sampling. Now what is random sampling or simple random sampling? What is the meaning of the term random? Random means what? Who can tell me what is the meaning of the term random? হ্যাঁ
স্যার র্যান্ডম মানে যেটার কোনো সিরিজ নেই,
যেটা কোনো সিরিজ নেই, yes. So what is how
সিকোয়েন্স ছাড়া।
we, yes, random,
Unrestricted.
yes, বলো বলো কে বলছিলে বলো।
স্যার সিকোয়েন্স থাকবে না যেটার কোনো।
Yes, random means without following any order, haphazard. So random sampling, the example that I was giving is that from the 10,000 bottles, the quality control inspector was choosing 100 bottles. Say maybe he has chosen second, fifth, 35th, 491, 723, like that, this way. So second bottle, fifth bottle, 35th bottle, 491 bottle, 723, 777, then 800, then 957, like that. So those number of bottles he is picking up. This way he will be picking say 100 bottles. So that is what is called random sampling without following any particular order. Without following any particular order. So that will be termed as a simple random sampling. And there are several other kinds of sampling methods also. Quota sampling, stratified sampling, and other methods also. I'm not going into the details of that. Our importance is the simple and random sampling. So simple random sampling, there are two types of simple random sampling. One is called simple random sampling with replacement. Another is simple random sampling without replacement. Simple random sampling without replacement. Simple random sampling with replacement and simple random sampling without replacement. Now let's explain what is without replacement and with replacement. So, as I was saying that I am picking the elements from the population, and if I am replacing that element again, say that means I have given example that I am picking the first, third, 27th, 51, like that. So in simple random sampling without replacement, if there are say 10,000 elements, first picking the first one, the probability is 1 by 10,000. Now, since I have already picked one, so next one's probability of the picking the second one will become 1 by 9999, because the now we have one is already gone, so second one is, and third one will become so it will decrease. Without replacement means the element that is being picked up is not being replaced. So simple random sampling without replacement, in general that is the case. Without replacement is the process of simple random sampling. But if the population size is very small, if the population size is small, then we use simple random sampling with replacement. Now in with replacement, what we do, so whatever is picked up first, that is being replaced, that is being again kept in the population, and the probability remains unchanged. Say suppose I am choosing in a say like example, like suppose I want to make different committees from the MBA first year class. So MBA first year, there are say 40 students. I want to make 5 committees: sports committee, cultural committee, cultural committee, uh, then say all study material committee, like that. Say I want to make different committees. So I choose roll number 1, roll number 13, roll number 25. Say I'll be making uh, committee of 5 students each. So I have chosen 1, 13, 25, and for, uh, 30, 36 in sports committee, suppose. And then I tell, okay, for the cultural committee, you go back and I choose from again from all of them. So it's possible, then I choose 13, 16, 25, 29, and 40 is the second committee in the cultural committee. So that means this is with replacement, because I can choose roll number 13 again for the cultural committee. If same element has the probability to be chosen in the other samples also. So that will be termed as a random sampling with replacement. And without replacement hole ki hoto, I have chosen 1, 13, 25, 36. So 5 students, 4 students, 4 students, okay, 36, 39 suppose. So 5 students are already gone. There are 35 students left. I'll choose the cultural committee from the remaining 35 students, and then this 35 5 more students are gone. Then I'll choose the study material committee from the other remaining 30 students. So that will be termed as a without replacement. And with replacement, in with replacement, same student could be, it is possible to choose the same student in different committees. Okay, so this is what is called simple random sampling with replacement. Generally, when the samples, when the population size is really large, very large, then we go for simple random sampling without replacement. And if the population itself is small, then we use simple random sampling with replacement. Now we will discuss sampling distribution of sample mean. Of sample mean. Now think about this. Please try to understand the basic. Sound হচ্ছে বন্ধ করো অডিওটা. Sampling distribution of, now please try to understand this very carefully. Suppose this is the population and I am choosing, say, I am choosing m samples of size n. From the population, I am choosing m samples of size n. ঠিক আছে? তার মানে প্রত্যেকটা স্যাম্পলের there will be n elements and I will be denoting the sample like this. So first sample I'll be denoting as x11, x12, x13 dot dot x1n. So that means this first suffix will denote this is the element of the first sample. See, for each of this the suffix begins with 1 and the second suffix varies 1, 2, 3 and goes up to n, because as said each sample will be having small n number of elements. So the second sample will be having x21, x22, x23 dot dot x2n. So this is the second sample and this way I'll choose m samples. So x m1, x m2, x m3 dot dot x mn. Either it is simple random sampling with replacement or without replacement, doesn't matter, but each of them will be having, in each sample will be having n elements and there are m samples. Now I'll be denoting the average sample mean of the first sample as x1 bar, second sample as x2 bar and dot dot finally the mth sample as xm bar. I think we have denoted the mean as bar. So sample mean means I'll just add this n values and divide by small n. So that gives you my x1 bar. So x1 bar means average value, average of the first sample. Similarly, it's the x2 bar gives you the average of the second sample and finally it's the xm bar. Now it is our objective is to find out how this x1 bar, x2 bar, xm bar behaves. So that is what is called the sampling distribution of sample mean. How this x1 bar, x2 bar and xm bar is, what probability distribution this average sample means follow. So that will denote the sampling distribution of sample mean. And if I say, and it is intuitively we can say that x bar is the mean of all these means. So x bar if I denote as, which is x1 bar plus x2 bar plus dot dot plus xm bar by m, because there are m samples. So if I take the average, and that will be termed as the average of all the means. So how they behave and how accordingly the sample mean behaves. So that part will be termed as the that is termed as a sampling distribution of sample mean. Okay. Now there are two theorems. One is called law of large numbers. Another theorem is central limit theorem. These two theorems are essentially, they say the following things. Please try to understand what I'm saying. I'm not going to state these two laws, but I'll just try to interpret, I'll just try to explain what this two law means. So law of large number says, actually law of large number says if the population is large and if you are taking sufficiently large sample, sufficiently large sample means sample of size sufficiently large. In general, in our statistical methods, statistics we consider if small as n is greater than equals to 30, we consider that sample will be termed as a large sample. So whenever from now onwards, when you will be doing the summer internship, you when you will be doing something survey like that, you must choose sample size of greater than equals to 30. If you take 50 sample size, then the result that we obtain will be more or less good, more or less good. So try to avoid small sample size. So what this law of large number suggests, that if you take sufficiently large sample, then the characteristics of the sample will be similar to that of the characteristics of the population. If you choose sufficiently large sample, then the characteristics of the sample will be similar to that of the population. Just give me a minute. So as I was saying, if you are having sufficiently large sample, the sample will be having characteristics similar to that of population, and that is why I could have said the first example that I have given, that if the average height of the three samples that I have taken was 165 centimeter, then I could have said, because the sample size that I have taken was 100, isn't it? Then I could have said that the average height of all the students of Swami Vivekananda group of institution is near about approximately 165. I haven't said it is exactly 165, because as I've said, I was considering the sample which is a part of the whole and not the whole. So there will be some amount of error in it. So 165 centimeter was the average height of the all, could be possibly the average height of near about 165. It will be near about 165, the average height of all the students. So that is why I could have said that, because the characteristics of the sample is similar to that of the population if you are taking sufficiently large sample. Now, what is the meaning of sufficiently large sample? Now think about that. We have given the example of the rice cooking. We have given the example of the bottles, the quality control of Coke bottles. Now think about the another example. So say suppose there is a event in your house, and you have gone there to buy, say, 1 quintal 100 kg of rice for your home. So 1 quintal of rice. So this is your 1 quintal of rice, and what you have done, you have checked, say you have chosen, say, 200 grams of rice, picked up 200 grams of rice and checked on 200 grams of rice, and you think that is quite a sufficiently large sample, and you checked for whether there exists any defective, whether there exists any কাকড় টাকড় আছে কিনা তুমি চেক করছো তার মধ্যে। If you are satisfied with that 200 grams of rice while checking that 100 kg of rice, then you are making a mistake. So you have to check several 200 grams of rice from the whole population. Otherwise, the result will not be satisfactory. Similar example I have given, that about that mall, making of mall. So you have to, what you have to do, you have to divide the whole population in different groups, and then you have to choose from each and every area of the population, so that it covers the whole area of the population. The sampling process should be such that it should cover the whole area of the population, and then only, and it should be sufficiently large in size. Then and then only it will give you a proper result. It will give you a better result. So that is the meaning of the law of large number. And central limit theorem essentially says this: say x is a random variable which follows any distribution with mean mu and variance sigma square. Mind that x is a random variable which follows any distribution, whether it's a normal, whether it's a binomial, Poisson, and any logarithmic. There are several other distributions, we are not considering them. So x is a random variable which follows any distribution mean with mean mu and standard deviation sigma square. Then if you are choosing a then sampling distribution of sample mean x bar will follow a normal distribution with the same mean as the population mean mu, and standard deviation is equals to standard error of x bar. This is what it essentially says. So x is a random variable which follows any distribution with mean mu and standard deviation sigma or variance sigma square, same thing. Then sampling distribution of sample mean x bar will follow a normal distribution with the same mean that of the population, and standard deviation which is equals to the standard error of x bar. Now what is standard error of x bar? What is standard error of x bar? Now standard error of x bar is defined as the following. How the standard error of x bar can be? Let's go back to the random sampling part. So S let's write SRSWR. If sampling is simple random sampling with replacement, that means if n is small and okay, let's write in a different manner. Uh, Standard error of x bar is equals to sigma by root n. If, please write, you are writing, I hope you are writing, if n is large and or sample is
Size.
SRSWOR. So standard error of x bar is defined as sigma by root over of small n. If n is large, n is large means
Yes, sir.
n is greater than equals to 30, and sample is sample random sampling without replacement. If it is without replacement, the population is also large, so large sample can be taken. Then that particular, then we define AC of x bar as sigma by root n. And if SRS WR, then with replacement, that means population
Yes, sir.
and capital N is known, that is population size is known, then AC of x bar is equals to sigma by
Size by
n
root n
into
into n minus n.
n minus n by
N divided by n minus
plus
1.
1.
1.
So that
Yes, sir.
is simple random sampling with replacement, and n is small. So these are the, when n is large, then small n is large, then we use this, the previous one. When n is small, we use this particular formula of simple random sampling, and we use the standard error of x bar. This is true when sigma is known. For this to be true, for those this formula to be used, the population standard deviation has to be known. Otherwise, this cannot be done. If population standard deviation is not known, then we can use S as the sample standard deviation instead of sigma. Instead of sigma, instead of population standard deviation, we will be using small s. But small s, the definition of small s is like this. Small s is root over xi minus x bar whole square by n minus 1. This is sample standard deviation is known as xi minus x bar whole square by n minus 1. Instead of n, we have earlier, sorry, there is a summation sign. There is a summation sign. Summation xi minus x bar whole square by n minus 1. So if sigma is not known, then sigma is replaced by sample standard deviation, and sample standard deviation is calculated by this. Why n minus 1? We will discuss that in the next class.